take a look at our graph. It's a velocity versus time graph, and we want to know when the displacement is in the negative direction. Now, if I have a velocity versus time graph, what this is giving me is the speed of my object and the direction it's moving in. So looking at section A, I'm going negative 2 meters per second. What that tells me is I'm moving 2 meters per second in the negative direction. If I'm moving in the negative direction, then my displacement must also be negative. So this is going to be A. And then D also has a negative velocity of -1. So it's going to be D. And then that's because velocity is negative. So that is how I can tell I'm moving in the negative direction. So for the positive direction, looking at my graph, I can identify that B is going to have a positive displacement because the velocity is positive. And then for zero displacement, I can take a look here, and sure enough, C has zero displacement because the velocity during section C is actually equal to 0. Okay, so it has 0 velocity, which means we're not even in motion during the time from 5 to 8. All right, so what we want to do next is calculate the displacement for each section. Now, if you have a velocity versus time graph, you get the displacement from the area under or above the curve. Now, we're going to identify here our curve is at -2 meters per second, and we're going to draw the area up to the x-axis. So this is the area that I'm looking at. Now, the one side of my shape here is going to be -2 meters per second, and the timeline that I have here is for 3 seconds. Okay. Now, the reason I'm multiplying the length times the width is because this is a rectangular shape, so therefore that's the area formula that I'm using. If I had a different shape, I would use a different area equation that would correspond to that shape. So here we get -6 meters, which means my displacement during the time from 0 to 3 seconds was 6 meters in the negative direction. For part B, I'm going 3 meters per second in the positive direction, and that is from 3 to 5 seconds. So 3 meters per second for 2 seconds. So for this one, I'm also going 6 meters, but now I'm moving in the positive direction. Okay, so even though the times were different, the displacement was the same because the speed values were different as well. All right, for C, C is this section right here, right? So what that means is my velocity for this shape is 0 meters per second. So even though I'm going from 5 to 8 seconds, so that's 3 seconds, because I have no speed, my displacement is also 0 meters during that time frame. And then for the last section D, I have -1 meters per second, and then the time from 8 to 10 is 2 seconds. So this is going to go -2 meters during that last 2 seconds. Then it wants us to identify the total displacement from 0 to 10 seconds. So what I need to do is I need to add up the displacements from all the sections. So delta x for the total displacement is going to equal the displacement for A plus the displacement for B plus the displacement for C plus the displacement for D. Okay? So I guess we should put delta before all these. So that's going to be -6 meters plus 6 meters plus 0 meters plus -2 meters. So it's going to be -2 meters. So it's going to be 2 meters in the negative direction was the total displacement. In what section was the object at rest? The object was at rest during section C because the velocity is 0 meters per second, and we can see the displacement of C was also 0 meters. Oops, sorry guys. All right, so in what section was the object at rest? The velocity was 0 meters per second for section C, displacement 0 meters. Which section did the object move the fastest? So if we take a look, okay, we have we're looking at what's the fastest, right? So we have -2 is really 2 meters per second going left. This is 3 meters per second right. This is 1 meter per second to the left. So the object moving the fastest was B. They are moving 3 meters per second in the positive direction. Okay, so this is in the positive direction. And then for the last one, in what section did the object move the slowest but was not at rest? Okay, now some people might want to put -2, but it's talking about the slowest, not about the direction. So really, -1 is the slowest because that means D is going 1 meter per second in the negative direction. And 1 meter per second is slower than 2 meters per second in the negative direction. So section A, the motion is actually faster in comparison.